Very simple, and some of you may see this in your classroom. Not only
is 1. All right, what is the value of the green triangle to the blue? And green times red triangle, then the green triangle.
conclude that in a group of 3, number 2 remains standing, no matter where the starter is. Okay, now we're going to increase the group size by 1. Okay. Ben, why don't you start?
1.
2.
Out.
1,
2.
Out.
1,
2.
out.
Okay, now notice.
Started.
Ben started. He was number 1.
That's right.
I was 2, 3, 4. So position 1 remains standing. All right, let's see if it holds true no matter who starts.
Okay.
All right, Dawn, you start.
1,
2,
Out.
1,
2,
out.
1,
2.
out. Okay, so it holds true with four participants. So number 2 was the winner with just 3 participants. Number 1 was left standing and was the starter with 4 participants. And what they can do is have infinite amount of combinations. You can start with just 2 students. You can increase it and have 3 students, then have another student come up and go through it. And they should be able to determine where they would stand in order to remain standing at the end of the game. And they just absolutely adore it. And Ben, you're a very good sport for coming up and playing the game with us. This is a really good icebreaker for the very first day of school. It is excellent because not only are they playing together and they don't necessarily have to know their names, but they are sharing a logical thinking and problem-solving activity that has a lot of complex problem-solving skills in it, but they're having an absolute ball. And so I hope that you use it in your classroom. Now Janet's going to come back up and do another intermediate activity, and I'm going to leave 1, 2 out for you to copy.
Clear.
Hi. The first activity on this set I want to do is called the card problem. And with this you need a 10 cards numbered 1 to 10. And they need to be in a certain order. The certain order is so that whenever you have the cards in your hand, upside down, it's a real neat trick. These kids, once they learn the logic of arranging these, can go home and show this to their parents and really fascinate everybody with it. The trick is that when you take the cards that are in your hand, you take the first one, expose it or show it up and lay it down on the table, and it should be a 1. Then the next card you take and stick underneath your hand, and then the third card you expose and lay it face up on the table, and it should be a 2. And you continue going through this pattern until you have gone through all of the cards, and they should be in order according to
then know how that student answered them. This just adds a little added dimension to it and does challenge the students a little more. And let me tell you, they have a blast. Another idea is to use Pico Fermi Bagel, and instead of using numbers, use words. Say 3-letter words, 4-letter words. And as they start doing that, it does get a lot more complicated. And it is a lot of fun for them. And you've incorporated another subject matter into your area. Another game that they enjoy playing, and it helps them to think and develop a strategy, is called 4 in a row. For this particular activity, you will need some graph paper. I am using just a grid sheet, and because my squares fit right in those grids very nicely, that seems to be what's easiest for me. Of course, you may use anything, and you don't even necessarily have to have different colored squares. You could instead have each child pick a different geometric shape. One of them be triangles, one be squares, one be circles, and the other one rectangles, or whatever you want to do. Now, this is best played in groups of 3 through 6. Now, you may use a group of 4, whatever seems most convenient. You may want to have this game in the back of the room set up so that if a group of students finish their work early, they can go pick up their basket and get busy on something that is math-oriented and will keep their interest instead of visiting and throwing things, and you know how that goes. What they need to do in this game is they will take turns placing their color onto the grid. And their idea is to get 4 in a row. And while they are trying to get 4 in a row, they are also trying to keep their opponents from getting 4 in a row. So if an orange is placed and then somebody else says, well, I'm going to get a green, and then player number 3 comes along and says, well, I'm not going to mess with them. They've messed each other up. I'm going to start over here by myself. And then we have somebody else who wants a yellow, and then orange again, and then green decides, well, I could block her, or I could try for one myself. I think I'm going to try for one myself. And then they start trying to block each other, and they get very distracted. And the larger your grid, of course, the more spaces they will have to fill in and extend this game. Of course, the smaller number of players, the quicker an end maybe to your game may be. So you can use all kinds of different variety with this. Another idea of a problem-solving tool is, of course, the matrix, like Janet was explaining to you. Now, in our case, and I must stress that I use this with my students either later in the year, or I take a lot of time going through it with them the first few. This is a much more complicated matrix, as you can tell. The added dimension to the matrix is because we have 3 variables, and let me quickly read through this for you. Eric, Bernard, Bart, Sydney, and Ralph have dogs named in no particular order: Bowser, Fido, Rover, Snoopy, and Spot. These 5 dogs are, again, in no particular order: a poodle, a basset, a terrier, a spaniel, and a collie. From the clues given, try to determine the name and breed of each boy's dog. And then it begins to give you the different clues so that you can solve for the dog and the type. Now, the idea is you will sometimes have to mark going across that Eric maybe doesn't have a poodle and his dog's not Bowser. And then you may need to also transfer the same information down to a lower matrix to keep all of your information full. The first clue in this particular case, no dog's name begins with the same letter as that of its master. So you know that Bernard cannot have a Bowser and Bart cannot have a Bowser. Sydney cannot have Snoopy or Spot, and Ralph cannot have Rover. Now, you may either suggest to the kids to immediately transfer the information down or wait and see what kind of information you get. Rover is not Bart or Sydney's dog. Rover does not belong to Bart or Sydney. That means Rover can only belong to Bernard or Eric, so we're very close in finding who Rover belongs to. Spot's master and the owner of the spaniel both have names beginning with the same letter. So Spot's master and the owner of the spaniel both have the same letter. And you can go on, and I tell you what, I'm not going to do this one for you. What I'm going to do is let you know where I get a lot of these matrix problems. I have a book that has just become invaluable to me. The students love these matrix problems, and I put them in groups, and boy, they've gotten to where they can get them in about 5 to 7 minutes. Now, these are my 8th graders, but they are really good, much better than I am. And this particular item comes from a book called Quizzles. And you may want to jot that down and look for that in some of your other information. But it's a really fun time for the kids. And, as you can tell, very mind-bending. We're about to take a 10-minute break. This will give you lots of time to work on maybe Pico Fermi Bagel or lots of other different logic problems that we've given you. Spend some time working on these, so if you get stuck, you can call us and let us know. Enjoy your 10 minutes. We'll see you back in just a little bit.
Hi, and welcome back. We are going to work with probability, and then we're going to move into graphing. So I want to begin the probability section with two related activities. The first one is called two dice sums. In this activity, the children each need two dice, or you can have them work in pairs. And they take the two dice and add the numbers together. And we have a phone call. Please identify yourself and tell where you're calling from.
Yes, my name is Francis Hernandez. I'm from Region 1 in Edinburgh. I have a question for Dawn. We tried to communicate earlier, but we were cut off for break.
Right, we were expecting your call. Dawn's right here. She'll be on camera in just a second. Okay.
What can I help you with?
Yes, hi. We had a question as to whether or not you were going to do the logical thinking on who's done it. We've been trying to figure it out, and we can't come up with an answer.
We better take a minute.
On who's done it? Is that the name of the problem, or is it one that I did?
No, it's one of the ones on the package.
Okay. Did you put it in?
Yeah.
Let us get. Sorry about that. I sure didn't put it in there.
It was back to back when it went in. What happened is when it went into the center to have the black line sent out, it was double, and apparently we didn't indicate which side we wanted printed, so they printed both. Well, we were prepared for one side, but not for both. So.
Tell you what we're gonna do. I'm gonna sit over here and work it out, if I can. Now, I'm not saying I'm smarter than you, and if I can't get it, then all I can say is we will mail you the solution. If you will
Send
write.
a self-addressed stamped envelope, and we will mail you.
And we do, yes, expect our students to be able to do this, even though we can't. So, let us work on that, and we'll get back to you towards the end, okay?
We'll also let you know where you can get the book.
Oh, great. Thank you. Appreciate that.
All right, back to two dice sums. I don't even know where I'm at right now. I'm looking at the penguin. If we roll two dice sums and add the numbers that come up, there are 11 possible outcomes. But and the children can experiment with this. Let them play around with the dice and roll and see what are the different possibilities. Before you ever introduce this, if you do it as a group activity, you may want to say there are 11 possibilities and what are they, and then let them roll and call out probably numbers or whatever. Then extend it by saying if you roll the dice, say 10 times, would any one sum come up more than any other? And you want them to make a prediction. So you have them, or you can do a class chart, have them construct a chart like this that says prediction and results, and ask everyone in the room to make a prediction. And some may say their favorite number. If their favorite number is 7 or 12. If they like doubles, they may pick 2 or 6. 9 may be their favorite number. You may have some that like 11. So that it ends up being quite varied. And then have them sit, and you can do this with partners, and roll the dice 10 times again and record the sums as they roll on the class chart, which is what this is here. And you continue rolling, and we'll roll some here and we'll see how they come up. We have a 5, 9, 4, 10, 11, 8, I'm getting quite a range, 7, 5, 3, 6, 8, do a couple more times, 3, and 8. Okay. Now that we have done that, ask them to look at the answers and see why we didn't have 2, why we didn't have 12 or 6, what could be the possible reasons there. When you are talking about the combinations, I forgot to mention that ask them why there is not a 1. They need to understand or be able to pull all these things out so that it all applies to what they're going to do as far as they're analyzing for the results. Then ask them to make new predictions, and you can erase the chart. If you do this on the board or have a laminated form or do it on the overhead, erase and ask them to make new predictions. And once they have made their new predictions, then go ahead and have them roll 25 times. And you can do this by working in pairs where one person can record on an individual chart theirs, and then as the other person rolls 25 times, and then switch and one be the recorder and one be the person who rolls, and then have them post their results on a large chart, and you can either put it on the board or make a large one out of butcher paper. And then talk about why certain numbers come up more than others. And what you hopefully will lead them around to is the fact that there are more combinations for making a 6 or for making 6s and 8s and 7s than there are for making 1s and 12s. And ask them which one has the most possible. You want to extend it by saying which one has the most possible chances for, or possible combinations for coming up, which one has the least, and extend it that way. There are a lot of ways that you can take this, and the questioning is very good, and they're going to come up with a lot of things on their own, and you're going to be able to lead them in different directions. All right, the second activity is an extension of this. Once you have gone through all of these activities and they pretty well know how the dice work, then you can play what's known as the 2-die sums game. And this is, you need 11 counters for each player and a pair of dice. Just one pair of dice and a number line for each player, and I'm going to show you the number line down at the bottom so you can see. The number line here is 2 through 12, and each player has a different set of and I'm using counters. We're going to use the 2 different colors, and the numbers should be large enough so that your counters fit on their plate. Now, I have only one number line on here to show them what the number line should look like, but each player needs their own number line. Now, the players can take their 11 counters and stack them any way they want to on their number line. If they want to put 1 on each, that's fine. Or if they want to put all of them on one number, say the 7, if they think, they're going to have the best possible chance that way. Or if they want to spread them out, they can put, say, a couple on 4, and they may base this on their own results from the game. And we have 4 on the 7, and maybe 1 on the 9 and 1 on the 8, 6, so on, and we'll put another one on the 6. And then the other player does the very same thing with their number line, using what they think is going to be maybe this one thinks 6 is going to come up more, so they put 5 on there and have hope for 12 coming up, and maybe the 2 coming up, 2 on 7, and so on until they have them spread out. Now you need to visualize them having another board here. Then each player takes turns rolling, and every player can remove. Now this can be played with more than 2. Sometimes to begin with it's good to have for just 2. But each roll, say I roll, the first player rolls 10. All right, that means that if either one of these players has a 10, they can take it off. If both of them had had a marker on the 10, they could both take them off. If I rolled a number, I would never believe it. Okay, the 2's come up. So this player can remove theirs. I want to roll one where they've stacked it a lot. Here's the 7. All right, this player has 4 chips, 5 chips on here. They may only take off 1 at a time, and this player may also take off 1. So that the first person to have all of their markers removed from the board is the winner. It's a real easy game, and it's one working with the predictions, deciding, because they are predicting by putting down their markers, they are making a prediction as to which number is going to come up more than the others on their on the rolls of the dice. They're also using some logical thinking. So these games have a lot of uses. One thing that we wanted to mention was that on any of these games, they're excellent to put into centers. You have a box full of folders and the pieces that it takes to play the games, and when they're through doing their seat work or what other activities, they can go to the center and pull out a game and take them to their desk, and they're having a lot of fun, but they're also building excellent math skills. I'm going to turn it over to Dinah now, who's going to do some primary activities through probability, and I'll be back.
The primary activities in probability that I've selected this evening are very much related in that the students are given a number of chances to explore dice throwing, spinner spinning, and recording the results. The easiest one that I want to start off with is how many rolls, and it is very simple. My folder is open-ended so that I can use it for a number of different numbers. You roll a die until A, and I have left that open-ended, comes up. Record how many rolls it took. Do this again 5 times and record the results. I have it open-ended so that I don't have to make a folder for each, like 1 or 2 or 3. All I have to do is go in and fill in this line for whatever number. And so it is open-ended, and it can be used for 6 different numbers. I'm going to go ahead and show you how this works. And what they're going to do is record their results. And it's very important that you stress and reinforce having the students record what they are doing. I do this by just walking around and observing them as they play the game. They can do this in partners, they can do it individually, they can do it in groups of 4. I found that as a class, it's a little bit tedious with some of the older students because they want to speed it up. As a class, it tends to bog down a little bit. But let me go ahead and go through this. I use a very large dice for teaching purposes, especially when we do a whole class activity. But what I have found is that the commercial dice make so much noise that sometimes it bothers the teachers next door. So what I have the students do is make their own die out of styrofoam cubes. They can cut it and they can mark it with the appropriate dots in the appropriate locations. And so of course when they throw them on their desk it doesn't make any noise. So that helps. Okay, roll a die until and let's go ahead and do 1. Roll a die until a 1 comes up and record how many rolls it took. There's 1 and it's a 6. Let me go ahead. Okay, 3, 4, 5, 6, 7. Okay, it took me 7 rolls to get a 1. So with 7 rolls, the 1 came up. Now you do this 5 times to see if it takes you close to 7 rolls and have them with probability predict. Once they've had some experience in rolling the die, have them predict for the next 5 times when they think the 1 will come up, and then have them go ahead and find their results, and then have them draw some conclusions with their prediction. So they go and they roll it again. That's 1 roll, 2, 3, 4, 5, 6. We could be here all evening. 7, 8, 9, 10, 11, 12, 13, 14, 15. This could be frustrating. 16, 17, 18, 19, and I'm going to cheat, 20. So, of course now I know it, that's bad. 20 times. It's real interesting to see them as they continue to roll. You can see how I was getting frustrated and eager for it to come up so that I could continue on. If I did that, you can imagine that their anxiousness is going to be threefold, because they're going to want it to come close to the one that they did at first, 7, or any prediction that they might have. And the longer it takes them to get the number for it to come up, you can anticipate their frustration and encourage them. Now, wait a minute. You know, let's see how many times it takes. Maybe you might have a world record. You never know. Give them some kind of encouragement and have them compare those results. It's really a lot of fun and very little monitoring on your part. All you have to do is just walk around. And so that's a real easy activity. The next activity that I want to go over with you is Got a Match. This works in partners. They need, the only materials that they need are alike spinners. It can be numbered partition spinners or colored spinners, and I'll show you a variation on this with color. You and your partner are to spin your spinners 24 times. Each time you spin, you will either match or not match. Predict how many times you will match. Record your prediction. Then record your results. And one of the things that I found hard to get across to the students is to predict first. They are so anxious when you bring in a game and you say, in math today we are going to be playing a game. They want to get to that game and get going with it, and so you have to really work with them to predict first. Here are 2 alike spinners, and as you can see they are commercially made, but of course you can make your own spinners using paper clips and tape and a disc where you spin the disc. And in the book that we use as a resource, which will be in a bibliography if you want to write for it, it's an excellent little recipe for drawing or making a spinner that is foolproof. It doesn't stick or bend or whatever. Now, what they do is they make a prediction on how many times it will take them to match. So, and they record their prediction. So I'm going to predict that it's going to take, so that I can move right along with my activities, that it's going to take just 3 rounds. So I predict 3 rounds. That's how long it's going to take, 3 rounds. So let's see if my prediction holds true. A 3 and a 3. Wonderful. It's right on the line, by a nose, it's there. 1 round. 1 round. And have them continue this. How many times do you think it will take for you to match again? And have them, see? There it is, a 3. Now, I find with manipulative sometimes that precision is, especially with younger ones, they want it very cut and dry. And so the larger the spinner, where they don't have to guess whether it's on the line or not, takes care of a lot of management problems in the classroom if they have a dispute about it or whatever. But this is a really good one. Like I say, please reinforce predicting first and then finding your results. The next activity is dice toss, and it too is just rolling the dice and finding out which numbers come up. Now, unlike the other one where you were actually just recording the numbers of times that you rolled, here you're not only going to record it each time you roll, but you're going to record the number. And I have a grid here that you can use, and you can do this much like a graph. All right, toss the dice, and then here it's open-ended also. So many times I've left it open so that you can do it for your kindergarten students, say 4 times, or 6 times, or 25 times. That way it is open-ended for just any level you want. All right, so we're going to roll the dice, and a 5. We received a 5, so we're going to record 5. We're going to roll it again, and we got a 2. Roll it again, and we got a 5. Roll it again, and I'm just going to do it a few times. We got a 2. Fascinating pattern here. Roll it again, and a 3. A 4. Another 4. And once they have rolled it for the specific number of times that you want them, have them look at this and have them draw some conclusions about the number of times that a certain number comes up on the dice. And you can have them really make some fascinating conclusions, because more than likely this will change with each time that they do this. You might want to have them roll the dice 10 times and then have them roll it again and compare their results and see if they can draw some conclusions with that. So that's another excellent activity. The next activity that I want to go through is pick a number. Now this does come from a worksheet. Pick a color, pardon me, pick a color. And this is a really good activity because it works with probability and having them make some predictions. First, you place a red tile, a blue tile, a yellow tile, and a green tile in a bag. And I have done that in my bag, and I just went ahead and used Unifix cubes. Okay? And what they do is they pick one, and then they record their picks. All they do is they reach into the bag, they pick a cube, reach into the bag, pick a cube, and then they record their results. Now, when they record their results, you need to reinforce, have them put it back in the bag. Because eventually, if they pick it 20 times and don't put the cubes back in the bag, their results are lost because there are no cubes in the bag. So I found that one time I introduced this activity, and did not mention putting the cubes back. And after 4 picks, they picked all the colors, and they were looking at me like, this is no challenge, this is not a game. So we had to go back through putting the cubes back in the bag. And so they record their results. And this is really a lot of fun in a lot of fun of probability activity. The last activity that I want to go through is numbered cube toss. And what you're doing here, you are rolling a die and recording how many times each number comes up. This one relates very well to the other one, except here you're using a 100 grid. So this is an excellent extension for the other one that was more simple. Here they're actually recording, like here's number 1, I roll the die and I got a 2 on the die. So you can see how this could take quite a bit of time in going through this. And I told you I wanted to give you the extension with a colored spinner, using a color spinner. And you can divide this into as many colors as you want. Here they have red, yellow, green, and blue. Spin a color wheel 28 times. After each spin, color in a box on the graph for the correct color. What do you notice about the results? Here it does not say predict how many times, but I always, in every single probability activity that I have the students do, I always have them predict first to see if they could make a guess as to what will come up the most, what will come up the least. Now, Janet's going to come back and do another probability activity with you.
Hi, the next 2 activities that we are going to do are basically related. They are, the first one is called How Many Throws? And in this activity, the children need a partner and 2 dice of 2 different colors. So we're going to use red and white. I'm up here. There we are. Red and white. Okay. Now, one will roll the dice and will make tally marks on the, and I'm going to go ahead and push it up so you can see the where they will record. One will roll the dice and do the tally marks here. The other child will record the results of the dice throws. And there are 2 different, they need to be aware of if it is a 1 white, it can be a 2 red, or that it can be a 2 white and a 1 red, and that there is a difference. So that you will probably need to discuss with them. So you begin by rolling, and this is the first roll. And you continue doing this until the chart is complete. So for this one, we have a white 2 and a red 5, so they will record here. Or we'll put an X here, and we're recording our throws over here. So you just mark it out. We now have one of those. And you continue rolling again. Here is a white 4 and a red 4, so here's an X here. Now, we have asked them why. You may want to ask them why that on the doubles you eliminate both. It's not different like it is on the 3 red and the 2 white and vice versa. That once you have it, then it's both eliminated, and have them talk about that. All right, here we have a red 3 and a white 6, so we have red 3 and the white 6 goes here. And they continue until this is completed, and they have, during this time, recorded their, the other person has recorded their roles, which I wasn't doing very well. And it's important that they keep this up, because in the end you're going to post how many times it took to complete the chart. Of course, like with all of our probability activities, you're going to begin by asking them to predict how many rolls they think it will take to complete this chart. And you may want to extend this by looking at it by analyzing the different combinations. You have a 1, 1, 1, 2, 1, 3, and so on, and coming up with the number of possibilities that there are, and then saying, well, so you could have at least how many rolls before the chart is complete. And then, but what if you keep rolling the same number over and over? How many will it take then? And do some extension with that. Then after you have done this activity, you'll want to have them fill in the chart, this chart. And then there are some other ways that you can extend this chart. It's called how many ways. And you have done the previous activity with the 2 different colored dice. 3, 1 is different from 1, 3. After you've completed the chart, answer these questions. All right, completing the chart as such, to roll the 4, it took a 2 and a 2, a red and a white, or a 3, 1 and a 1, 3, and how many total possibilities were there? Well, there were 3 possibilities. And they go through each one of the numbers. In order to do the 2, there is 1, 1. The only possibility, so there's only one total way to do this. Now, once they have completed the chart, they add these numbers across here. And if the total comes up to 36, then they're right. If it doesn't, there's a problem somewhere, and they need to go back and count up and go through each one of their possibilities to see where the mistake is. Then they list the possible totals in the order of which has the most possibilities down to which has the least. Now, the next thing that they can look at would be the probability of rolling 7 is 6 chances out of 36, and show them how mathematicians write it, either the 6/36 or 1/6, and why. And then what is the probability of rolling each of the other sums? In other words, take this same concept here and apply it to each of the other sums. Then add up all the possibilities for each of the sums, and what do you get for that total? In other words, this is an extension activity that is just dealing with addition, where they take and they add up the possibilities. Here was the 2 and 2, that's 4, 3 and 1, that's 4, and 1 and 3, and that's 4. So you have 12 here, and this is 1 and 2, so that's 16, and they go through each one of these and come up with the total. And that's just an extension activity past the probability. But it's important that you do ask them to make the predictions before they go through the actual activity, and then compare what they predicted to what the outcome was. All right, I'm going to turn it over to Dawn now, who will go through the middle school activities.
Okay, I've been working real hard on that problem. I did find it, and it was mine. It came out of the book of Quizzles. So I do need to get that bibliography to y'all, and I am working on it, but I have two people with the same weapon, so I'm in trouble. I have to go back and check my sources. What I'm going to go over is some of the different probabilities that do occur in the middle school. Probably a lot of this can be adapted for lower level and then extended on up for higher level. I'm sure you're very familiar with the coin toss done in every single book, I'm sure. What I just want to encourage you to do with your students is don't just teach them how to determine probabilities, but let them try it and see why it is we do what we do. For example, if you have two coins, and let's say that we have a nickel and a dime, what are all the different possibilities you could have? Well, you could have the nickel and the dime both be heads. You could have the nickel be heads and the dime be tails. The nickel could be tails, the dime heads, or you could have them both be tails. And as they begin to look at all the different possible outcomes, you may want to have them predict this in several different ways. Use each category individually, or you could say, what do you think would occur most often? Two heads, different, or two tails? As they become more familiar with this, they will, of course, pick the ones that are different because there are more chances of getting the two different categories, and have them discuss why. With three coins, there is, of course, an added dimension to that, and there are different possible outcomes. Now, I love to do this, and I made myself a little cheat sheet just in case I got frazzled, but what I like to show them is how hard it is to go through and count all the different possible outcomes. And we start going through, it could be head, 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 and head, head, tail. And in fact, what I like to do is take these suggestions from them so that they're not done in any specific order. If they're done in a systematic way, you can pretty much get all the different outcomes. But I like to take it from them, and then when they think they have them all, and I have 6 written down here, and I know that I need 8, I can say, no, we're still missing 2. And they would say, well, how can you tell how many you need to have? And then that leads me very much into showing them Pascal's triangle and relate it to how you can determine some possible outcomes. Remember that if you only have 2 different choices, heads or tails, suppose we had 4 coins. Well, if I have one coin, this is 2 to the 0 power, which means I have 1 outcome. If I do have 1 coin, 2 to the first means I have 2 different outcomes. If I have 2 coins, as the exponent shows, I have 4 possible outcomes, which if you add, that's where you would get this number. I think I'm off a line, excuse me, on the triangle. If I have 3 coins, I have 8 possible choices. 4 coins, and I would have 16 possible outcomes. And then they realize that this makes it much easier to determine the hard part. And of course, determining your possible outcomes with many different events becomes very confusing. The problem I always enjoy giving my students, and this may work for you and it may not, but they do have outcomes. You have outcomes sitting right there in your class. You can vary this. It may depend upon what area you live in, whether you have a lot of families with lots of kids. You may want to increase this. In this particular case, I like to explain to my kids that, you know, my husband and I have planned everything out on how we're going to have kids. And we are going to have 3 kids, and we also know that we are going to have 2 boys first, and then we're going to have a girl. And we just know that it's going to happen that way. And how would that occur? And what is the possibility or the probability that it would occur? And then what we would need to do is go on and list all the different outcomes with the children: boy, 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 girl, boy, girl, boy, girl, boy, boy, then girl, girl, boy, girl, boy, girl, boy, girl, girl, 1, 2, 3, 4, 5, 6, 7, girl, of course I can't get it now, but on the bottom it's girl, girl, girl. I'm sorry, I didn't follow my little cheat sheet, now I'm stuck. Anyway, there are the 8 different possibilities here, and as the children start to talk about this, what I really love to do is to bring into this what is your situation and what are the outcomes we have sitting here in the class. I'm going to stop for just a second. I believe we have a caller. Could you please identify yourself and where you're from?
Yes, this is Francis Hernandez from Edinburgh, Region 1.
Yes.
I'm the one that asked you about the problem solving on logical thinking on the whodunit.
Yes.
You said you couldn't come up with the answer?
I don't have it all yet.
Okay. Let me ask you this. What do you think the possible outcomes will be for us to figure that out?
I'm sorry, what did you say?
My question is, what do you think are the possible outcomes for us to figure that out?
Well, man, now you've got me so stumped I can't even answer your question. Well, I think that you guys, if you get your heads together, you could figure it out right there. What I may do is at the very end bring in my solution of what I have and show you how to sum it up, even though I can't get it. Of course, I've only been working on it now for about 10 minutes, and it took us a while to find the problem. So I think that in a group of 10 that a lot of you could do it. So you just keep working, and I'll get back to you. Huh?
You mentioned a book you got it from. What was the name again?
It was called Quizzles. Quizzles.
Where can we get a copy of it?
What I will do is, if you will write into us, I will send you the bibliography and the company and all of that information. And I really apologize for not having that available to you at this time. Just let them know what session this is, and I will be sure to get that back to you because it's a great book. Okay?
Well, we appreciate you trying it.
Okay.
We'll work it out.
Okay,
Thank you.
thanks. Okay. Just to wrap up the birth order problem, what I really enjoy doing is talking about summarizing some of the different categories. How many of your families do have 2 boys and a girl? How many of you all have all 3 boys and all 3 girls? And you will see that the probability of that is very slim. But then you might also bring into account that, as statistics show, if you have 2 of the same sex, you are more likely to have another. If you have 2 boys, you're more likely to have another boy than you are to have a girl. And there's all kinds of neat information you can give them to interact with the uses of probability. And then, of course, to stress that that is a real-life probability problem for me right now. And my chances are very slim of having 2 boys and then a girl. But expound upon that, and they really enjoy getting into problems that will affect them and being a part of the results. Let me give you a few more ideas. Another item that's fun to do as a class in groups is called the bean population problem. What you need to do is just get a bag of white beans and 3 bags of brown beans, and you're going to put them in a pretty hefty sack. Put your kids in groups of 4 so that they will have more materials and more sources to draw from. Each child, you'll go around the room, will get a small handful of beans, and then they will, among their group, compare all the different combinations that they receive. One child may have 5 brown ones and a white one, and the other child may have 3 browns and 2 whites, or whatever it is. And as they begin to compare these results, they need to determine an answer for the question, if 4 beans are drawn from the bag, just 4, which do you think would be more likely to come out? 3 white and a brown, 2 white and 2 brown, 1 white, 3 brown, 4 white, or 4 brown. It really is good for them to gather the data among their groups, assimilate and make a decision, and then to actually put all the beans back into the bag so that it remains a constant, draw out the 4 beans and see what happens. And in fact, do it several times and see which category appears most often, and then tell them, you know, which you did. Did you have 3 white and a brown? You know, if your beans were proportioned. It's really a neat tool for them to use to see the idea of probability. Some more probability ideas, and we probably don't have a whole lot of time to go through them, but I do want to stress a few things. I know that your students have all different kinds, especially at the 8th grade level, and I believe at the 7th grade too. They will have to do probability where they will draw a bean from the bag and keep it and see what the probability then is of drawing another bean out of that bag. For instance, if they want to know the probability, if we have 25 beans in the bag, okay, and we want to first draw a blue one, and then we want to draw a white one, okay, and the 25 beans are 15 blue and 10 white. What is our chances of drawing the beans in this order? Now, the reason why I really do suggest that you go around the room and do this visually is because it becomes hard for them to see why you multiply the fractions together and why your answer may get larger or smaller. The same holds true if you do put it back and pull out again. You will see that your chances, of course, are much better if you replace it if you're trying to get blue over and over again. I really think that the ideal situation for probability is groups of 4. You can just teach those students a lot faster what the kind of computation work they need to do using groups of 4. And if you get 2 independent events, simplify it way down. Use a dice and a coin. And dice are not hard to come up with. If you can't do that, see if you can come up with making a spinner. We showed in phase 1 how you can make a spinner. And use some of your tools in the classroom so that they can see why you multiply the 2 probabilities together, and then your answer becomes much smaller, because as they begin to try to predict what will happen, what are your chances of getting a head and a 6, it's quite small, 1/12 in fact. Well, if you roll and spin 12 times, do you ever get that number and combination that you want? So it's really a neat tool. I hope that you will use that. Let me tell you, we're about to move into our graphing section, and we've got lots of neat things that you can teach with graphs, not just graphs. And we are going to use a little different format for this. We will start with primary with Diana, and she will take you all the way through. Then we will move straight into the intermediate level and carry it on up through then the middle school age child, and try to just start with one concept, take it straight through. And I think that you're going to really enjoy it. Let me leave this up there for you, and we'll be back with you in just 2 minutes.
I was so excited about going into the primary graphing activities that I just grabbed that thing right off the screen. I apologize. What I want to stress this evening are very concrete types of graphs. I want to talk about body graphs and object graphs and three-dimensional graphs. And the first one that I want to talk about are body or people graphs. And let me just show you some little hints. It says students stand in a square or circle. This is good for small groups up to a whole class or classes. And let me show you what I use for small group work when we're talking about people graphs. This is clear vinyl. It is a heavy-duty paint tarp. If it's not the real thin kind that tear easily, it is a heavy-duty paint tarp, and it comes in rolls of 1,000,000 yards. You will never be able to use the whole roll. This one is just a small group bar graph that I have. We have one for the classroom that is floor size. Now, you may look at this and go, oh, what a mechanical nightmare to put this thing together. What I might suggest for you is to give a wonderful activity to all those fabulous and creative 5th and 6th grade teachers that might need a measurement activity for their 5th or 6th graders, and have them do it for you. And if you have a teacher that will do this for you with her students, it does help out. But what you can do here is you can put the different subjects and numbers right underneath this clear vinyl so that it's open-ended. Let me just show you how that works. Okay? You can just put anything underneath here and it comes up, and this is just some graphing ideas that we'll put up later, that it is very clear and you can see right through it. And the students go and stand right in the square where they belong. You can also do this with Venn diagrams, circles, and they can go and stand. You can also use this with objects where they go and put shoes on here, or books, or records, or whatever. And this is really a lot of fun. And whenever we pull this out, they know that it's going to be a fun whole class or small group activity that they can all participate in. Now, when they make choices in graphing, with the smaller ones, I have to overcome their wanting to make the graph or a particular section in the graph win. In other words, if students start selecting a particular subject and that bar is getting larger and larger, they want to take their choices and continue to make that bar go up because they want that to be the popular choice. One way that you can overcome that is as they are coming into the classroom, and I might want to show you an example. As they're coming into the classroom, have them make a choice. In color graphs, you can have them pick a colored square. They really don't know why they're doing it. You tell them, pick the color that you like. And they go and they pick it and they take it to their desk. So the choice has already been made. And an example is this graph right over here on the wall. Here, they have already made their choices. And when it comes to putting the choices on the graph, they don't have to deal with, well, we want green to win. They have already made their choices, and they come and they put it on the graph. So you can use this concept with really anything, and it works. And that way the graph is a more true representation of what they have selected or their choices. Object graphs are a lot of fun. Object graphs, you can use any object as a representation on a bar graph. You can use shoes, cookies, sandwiches, buttons, cars, fruit, anything that is an object that they can actually put on the bar graph. Rings that link together, where you can do, instead of a bar graph going up, you can do a ring graph linking down. And that's a lot of fun. They can go up there and link it together. Cups, pictures, small toys, and they can bring this in. You don't have to go and buy all this stuff. Small toys, have them bring it in. Clothespins. Now I want to go directly to the three-dimensional graphs. And I have some examples here of three-dimensional graphs. The first one that I want to show you are the sandwich graphs. And it's getting so late that the smell of these sandwiches are driving me absolutely crazy. But I do want to show you this graph. Here, you're taking two sandwiches and have the students place little flags into the sandwich as to their preference. Here we have tuna, and Beth and Robert and Mary like tuna. Here we have chicken, and Rachel and Chris and Ann, and who is this right here? Chad. Chad liked chicken. And so they can go and they can look at this and draw some conclusions about, which sandwich is more popular, how many like chicken, how many like tuna, how many more like chicken than like tuna. And so it is a three-dimensional graph. It's not your typical bar graph or your circle graph. It is a three-dimensional graph. And the next one that I want to use is the can with the flags in it also. And here they can put their flags into the top of, let's say, their soda preference. And then that way they can determine which ones they like and make some conclusions about which one's the most popular and so on. And the last one I want to do are animal cookies. And here they take the cookies, the animal crackers, and they select the one that they prefer and then go and put it on a bar graph. And so here's a gorilla, and all they do is put it on the bar graph. Another gorilla, a lion, and so you can see how a giraffe, a bear, oh, here's an elephant. I'll take care of that right quick. A kangaroo, and so on. So this is a lot of fun, a lot of fun. Now I'm going to put up some graphing ideas for you while Janet comes up here to do some quick intermediate activities.
Okay, I'm going to take just a real short minute, and then we're going to send Dawn in to finish it out. I want to kind of basically give you some maybe easy ways to do your graphing so that it's not a real time-consuming process, because we don't have a lot of time, I know, to make things that we can use in the classroom. We're so busy teaching. So let me begin by showing you that I have done a graph on a simple Venn diagram. Where do you fit? My eyes are brown, or am I, and I am wearing blue jeans. This has been put on with overhead markers so that when you're through with this graph, you can wipe it off and use the Venn diagram for a different type of activity. But they've all been laminated, the ones that I'm showing you. They're the basic ones, and they can be changed so that you can use them often. If you teach several sections of math, the main titles that you put on can be put on with a permanent marker. We have a phone call. Please identify yourself and tell where you're calling from. Yes, go ahead. What is your question? Hello?
Our phone rang a while ago. It's never done that before.
I promise you it wasn't us calling.
Okay. Thank you.
Uh-huh. All right, so you can erase all this. If you have several sections of math, if you are in an elementary school where you do departmentalize, or even in middle school, you can use the same titles over and over again by writing them in permanent marker, writing on the laminated surface with a permanent marker, letting the children record for each class with the overhead pins or with stickers. And I advise you that if you do use the stickers, please to buy the kind that are removable, because if they are not, they create quite a mess. For example, let me show you. This is another excellent. Let me get close up here. This is an excellent manner or graph to use, but when we tried to pull the stickers off, it left quite a mess, so be sure you get the removable kind. Once you've written on it with permanent marker, to change it, all you need to do is spray it with hairspray, and it will wipe right off, I promise. Let me show you some of the examples of the basic ones that you can construct. Now, if you only need 4 columns, you can just fill in your information here on the 4. If you need 8, if you need 10, another one, just add a couple of columns on the end for that day. This is another example of one that can be used where it's a two-way. They can fit here, they can fit this one here, and so on. This is a more complicated Venn diagram where you have 3 different possibilities, 4. Now this one is just a plain line one, and what you can do with this is create whatever lines you want on here. If you want just 3 columns going down with your answers here, if you want numerous ones going across there, whatever way you want to do it, this one can be turned to work this way or the other way. I held up a piece of grid paper. This is commercially made. It's excellent laminated. And what I want to share with you real quickly is that these can be used every day as attendance graphs. You can create a different graph every day. The children come in and mark them, and then they can be used every day by wiping them off. And eventually the children will get so good at this that they will be able to create their own, and you have the forms that they can create their own on, and they can then create the attendance graphs. But it's good to give them practice. Now I'm going to run right out of here and I'm going to turn it over to Dawn.
Okay, let me just briefly cap some of what they've said, and hopefully by the time the children get to the middle school, they've seen graphs done in class before. I don't know what kind of a program your school uses, but I find as classroom management, what works really good for me is to have the students, as they walk into the room, record the results on a graph and be seated. And then I have questions that I post about that graph. And while I am busy working on attendance and handing out makeup work and all of our busy work kind of chores, they are busy also working on some warm-up exercises. And these graphs can be invaluable review tools. You can bring up fraction. What fraction of the students, in other words, let's just look at a graph as an example. Right back here I have the graph, do you smoke, drink, do both, or just say no? And I was just real excited about how this came out, so I had to bring it and show it to you. These are my 8th graders, and as you can see, most of them did put just say no. Now I must say that these were done on student surveys, and what I did was allow the students to mark on their survey their own answer with nobody looking. So I felt like it was a pretty valid. This kind of a graph varies from class to class, of course. A lot of my other classes don't have so many in this area. But you can ask such questions as, what fraction of the kids smoke out of this class? Give me a ratio of smoke to just say no. What percent of the students in this class drink? And in that one, they would have to take the fraction and then convert it to a percent. And you can use these graphs really to teach just about any subject, any different topic. And students enjoy answering questions about some information that they're a part of. I really have received great results with this. When I first came into the middle school and started using the graphs, I was a floating teacher, so I had 6 different classrooms that I was in. And of course, I was carting my graphs around and my questions around, and used the laminating and had the students work on it with the overhead pens. And then at the end of class, a student was responsible for erasing it, and it worked great. It really did. Another idea that I do is, after they do become real familiar with these graphs, is I let them do their own graphs. And as I mentioned, I really enjoy doing student surveys. And what I usually do is, to prepare ahead, they have been introduced to all different types of graphs. We do discuss what is a good thing to have in a bar graph. There are some pictographs around. One of the top ones is the favorite kind of music, and they use different kinds of pictures to denote different types of music, and I thought that was very clever. We do need to stress at that point that one musical note, though, shouldn't be any farther out than the cowboy hat or a heart. They should all be at the same point, and that is a downfall of that particular graph, so that when you can glance at the material, they can easily see it, the answer. When the students do these student surveys, I like to say that we're going to find the typical middle school, maybe your particular school, the typical student, and what are their likes and dislikes, and what are some of their characteristics. If you use problems with numbers, such as how long do you spend on homework each night, and you do get exact numbers, then you can discuss mean, median, and mode, and which tells you the most. Does the mode tell you a lot about this graph, and then what would the median be? You can just introduce all kinds of topics with these graphs. I really encourage you to use them, and it doesn't take much time. It really doesn't, to make them. The student surveys and the graphs, they've really had some fun with. If you're interested in seeing, these are some elementary school individual graphs. What I like to do is give them graph paper and have them do some very nitpicky graphs with lots of information. All I do is just give them gobs and gobs of information that I've received through the years on different topics that they are interested in. What you might want to do when it comes to student survey time is let them submit the answers that will be recorded on the survey or the questionnaire. And in fact, one of the projects that another math class did was they distributed their typical student surveys to every math class in the school, so every student in the school, not just your own students, but everyone filled one out. And that gave them lots of numbers to work with and to get some real neat percentages. I hope that this has been beneficial to you. Diana and Janet are going to come back now as you glance at some of these graphs, and we will close out the session. We'll be with you in just a minute.
We want to thank you so much for participating in this in-service. We hope that you have received a lot of ideas for your classroom, different activities, management ideas that will really get you going and get you enthusiastic about teaching problem solving. At the end of the program, we will be putting up the address that you can write to get your information, the packet that you want. I remember last night someone asked specifically for level information and also a phone number if you want to call. Anything that you need, we will be more than happy to oblige and get to you. I want to also remind you that this is for ATT credit. On behalf of Janet and Dawn and myself, I want to thank you again for joining us and hope that you had as much fun participating in this in-service as we did in giving it. And we hope to see you soon in another in-service. Thank you.
Seitdem, ja, there
Okay, I'm going to take just a real short minute, and then we're going to send Dawn in to finish it out. I want to kind of basically give you some maybe easy ways to do your graphing so that it's not a real time-consuming process, because we don't have a lot of time, I know, to make things that we can use in the classroom. We're so busy teaching. So let me begin by showing you that I have done a graph on a simple Venn diagram. Where do you fit? My eyes are brown, or am I? And I am wearing blue jeans. This has been put on with overhead markers so that when you're through with this graph, you can wipe it off and use the Venn diagram for a different type of activity. But they've all been laminated. The ones that I'm showing you, they're the basic ones, and they can be changed so that you can use them often. If you teach several sections of math, the main titles that you put on can be put on with a permanent marker. We have a phone call. Please identify yourself and tell where you're calling from. Yes, go ahead. What is your question? Hello?
Our phone rang a while ago. It's never done that before.
I promise you it wasn't us calling.
Okay. Thank you.
Uh-huh. All right. So you can erase all this. If you have several sections of math, if you are in an elementary school where you do departmentalize, or even in middle school, you can use the same titles over and over again by writing them in permanent marker, writing on the laminated surface with a permanent marker, letting the children record for each class with the overhead pins or with stickers. And I advise you that if you do use the stickers, please to buy the kind that are removable, because if they are not, they create quite a mess. For example, let me show you. This is another excellent. Let me get close up here. This is an excellent manner or graph to use, but when we tried to pull the stickers off, it left quite a mess, so be sure you get the removable kind. Once you've written on it with permanent marker, to change it, all you need to do is spray it with hairspray, and it will wipe right off, I promise. Let me show you some of the examples of the basic ones that you can construct. Now, if you only need 4 columns, you can just fill in your information here on the 4. If you need 8, if you need 10, another one, just add a couple of columns on the end for that day. This is another example of one that can be used where it's a two-way. They can fit here, they can fit this one here, and so on. This is a more complicated Venn diagram where you have 3 different possibilities, 4. Now this one is just a plain line one, and what you can do with this is create whatever lines you want on here. If you want just 3 columns going down with your answers here, if you want numerous ones going across there, whatever way you want to do it, this one can be turned to work this way or the other way. I held up a piece of grid paper. This is commercially made. It's excellent laminated. And what I want to share with you real quickly is that these can be used every day as attendance graphs. You can create a different graph every day. The children come in and mark them, and then they can be used every day by wiping them off. And eventually the children will get so good at this that they will be able to create their own, and you have the forms that they can create their own on, and they can then create the attendance graphs. But it's good to give them practice. Now I'm going to run right out of here and I'm going to turn it over to Dawn.
Okay, let me just briefly cap some of what they've said, and hopefully by the time the children get to the middle school, they've seen graphs done in class before. I don't know what kind of a program your school uses, but I find as classroom management, what works really good for me is to have the students, as they walk into the room, record the results on a graph and be seated. And then I have questions that I post about that graph. And while I am busy working on attendance and handing out makeup work and all of our busy work kind of chores, they are busy also working on some warm-up exercises. And these graphs can be invaluable review tools. You can bring up fraction. What fraction of the students, in other words, let's just look at a graph as an example. Right back here I have the graph, do you smoke, drink, do both, or just say no? And I was just real excited about how this came out, so I had to bring it and show it to you. These are my 8th graders, and as you can see, most of them did put just say no. Now I must say that these were done on student surveys, and what I did was allow the students to mark on their survey their own answer with nobody looking. So I felt like it was a pretty valid. This kind of a graph varies from class to class, of course. A lot of my other classes don't have so many in this area. But you can ask such questions as, what fraction of the kids smoke out of this class? Give me a ratio of smoke to just say no. What percent of the students in this class drink? And in that one, they would have to take the fraction and then convert it to a percent. And you can use these graphs really to teach just about any subject, any different topic. And students enjoy answering questions about some information that they're a part of. I really have received great results with this. When I first came into the middle school and started using the graphs, I was a floating teacher, so I had 6 different